Ini Kaizen juga bro.
Okay. Now we will continue our discussion. We learn about this is we call it. We learn it about mathematical model about strategies. This is a mathematical theory that gives general picture of competitive situation. So in this we have competitive situation. And then final outcome depends primarily on the combination of strategies selected by adversary or competitor. So this is depends on the strategy. We have a strategy and our competitor we have strategy. We seek for the can be maximize or minimize depend on the situation. The main goal of game theory is to develop functional criteria for choosing strategy. The strategy we have player one. Maybe as a player one, we have some strategy and competitor or we call it player two. They also have strategy. Can be same, can be. In game theory, we have assumption. All players are have a rational mind, and all players use their strategy for the opponent game. In this game discussion, we only take 2%. Zero-sum. In game theory, there are 3 and extra percent, but for this lesson we only learn about this one. We limited at this one. Okay. So what is 2% zero-sum game? Involve two players, player 1 as BR and the competitor as player 2. And then the amount of winning player equal to the amount of losing player. So if the player 1 he get plus 3, so player 2 he will lose 3. This is equal amount of losing player. The first one is gain. This is lose. This is lose. This is win. This may be this is assumption. The net winning of good player equal to 0. The net winning because they have like this one, so the net winning of the player equal to 0. Characteristic 2% gain. The first one, there is a choice of strategy of player 1. We can A, B, C, or this is depend on the situation, study case. Like this. There are strategy options for player A, competitor, and there is a payoff table. Payoff table is one. So this is from the perspective of player 1. So the payoff is the from player 1. Because we in the player 1. Strategy. This is a predetermined rule that specifies concretely how one intends to respond to each possible sequence of like the payoff. So this is so the game for player 1 that could be some from its combination of strategy of the two players. So this is from the perspective of the each player, we have two players. If each player points one or two fingers at each other at the same time, if the number of fingers came out equal, so the number is even, then player 1 wins a gift of $1 from player 2 and vice versa. Is player strategy showing 1 or 2 points? So, so for player 1, they can point one finger or two fingers. Player 2, they want one finger. If the number of fingers is equal, so if 1 and 1, the player 1 gets 1. 2 and 2, they get 1. And then if they get, this is we make some payoff cycle from player 1 and player 2. That is for this. So the value positive, then profit for player 1 is also loss for player 2. If value is minus, then the loss of player 1 is also positive for player 2. We have another example to model about the payoff table. First one, two politicians are competing with each other to be able to sit in the representative. And then the campaigns must be carried out in the last 2 days. They have 2 days remaining. And then the two politicians want to spend the campaigns period in 2 cities. We have 2 cities, Surabaya and Malang. We have 2 days. How did the politicians spend the 2 days on the campaign period in order to increase the vote? So we have 3 studies. 1. We spent 2 days in Surabaya. And then second, we have 2 days in Malang, or 1 day in Surabaya and 1 day in yes. So this is the strategy that can be spent 2 days in Surabaya. Oh, this is strategy 1. This is strategy 2, and this is strategy 3. This is depending on you. If you have exam, you can determine which strategy. And then, like this is, we make some. So strategy 1, spend a day in each city. Strategy 2, spend 2 days in Surabaya. And strategy 3, spend 2 days in Malang. Usually, the take of this one will be given in the equation. Okay, this is payoff table formulation, and this is the example of the payoff. To solve game theory, we have 3 variations. We have 3 variations. This is we call it pure strategy. This is we call it mixed strategy. Variation 1 and 2 pure strategy and mixed strategy. What means pure strategy? We can choose one or two strategy 1, strategy 2 or strategy 3. But in mixed strategy we have probability. Probability. So this is the first example for variation 1. We have like this. So for the pure strategy, for politician 1, this is a payoff table. This is total vote won by political 1. So this is from the perspective of politician 1. So they will get 1,000 voters if they spend a day in each day. But if they spend, they have strategy 1 and politician 2, they have strategy 1 too. So they will get 1,000 voters additional food that's linear by politician 1. But if they choose strategy 3 for politician 1, but for politician 3 they choose also strategy 3, so they will lose their voter. They lost 1,000 voters like this. So this is depend on the data. So this is one for the pure strategy, the first variation. So we check. This is one because politician 1 want to maximize. So we search for the maximum. That is, for this one, we seek for the minimum because politician 2, if we, from the perspective of politician 1, we must take for maximum. But for the politician 2, they will not choose this one because they will lose large amount of the voters. So they will choose the minimum. If the player is rational. So for the player 1, this is we seek for the maximum for its column and for the minimum for the root. That is, from this maximum, we seek for the minimum from the maximum. We call it minimax. Minimax, so we can get 1. And minimum, we seek for the maximum, so this one. If the minimax and the maximum is the same, this is 1 and 1. So the minimax is the minimum value of maximum number of column, and maximum the maximum value of the minimum number of lines. So we have a central point if minimax sama dengan equal to the maximum. So we can choose two strategy with minimax. If we take a look at this one, we have 1. For maximum we have 1, and for minimax we have 1. So we can direct know that this one is optimum. So player 1 choose strategy 1, and player 2 they choose strategy 1. Both of the politician they choose 1 strategy. This is for variation 1. Okay, your strategy. The other way to solve this vocabulary, we can remove dominated column and rows. So for the politician one, we this is from the perspective of politician one. We take a look at they dominated. Remove strike dominated column and row, the line with the smallest number, column with the largest number. So we seek for for the line we remove the smallest number. Why? Because from the politician one we consider that they have small number if we compare with the other strategy like this one 1, 2, 4 they dominated 0, 1, minus 1. So from the rational perspective, logically, so we can remove this strategy because from the politician one they want to have more game, more voters. So we can remove this strategy from perspective player one. And then from perspective from player 2, like this one. From perspective player 2, rationally, they will avoid this one because they will lose a big number like 4 and 5. So we can remove for the largest for the column and smaller for the line. So we can eliminate dominated column and rows with the line with the smallest number and column with the largest number. Like this one. So we can compare 1 and 2. This is dominated. This one. This is the largest element. So we can remove it. So from the variation one, for politician, take strategy one. Politician one will get off 1 from politician 2. Politician get 1,000 votes from politician 2. Take off 1 game value, 5 game 0. Uneffectivenya not equal to 0. This is for variation 1. So we can solve the minimums and maximum. Variation 2, like this one. This is the same. I think the same with the radius. So like this one. In the same case study, but different type of pattern. So we have like this. So we get 6 for the maximum and minimum. We search for the maximum and minimum. And if minimum equal to maximum, they have a stable solution. And game value is 0. Yes, game value is 0 because it's not 0. And then politician 1, they choose strategy 2 and politician 2 choose strategy 2. Choose the strategy with the largest minimum payoff. Player 2 choose the strategy with the smallest maximum payoff. Maximum equal to minimax, this is stable point, so this is a stable solution.
Sorry, bro. Does game value means the saddle point or what? Does game value, what does it mean? Game value.
Game value is one.
The what?
Saddle point.
The saddle point.
Yes.
Okay.
Payoff 1, Okay, I'm sorry. Game value is 0. This is because this is a zero sum game. Oh, I'm sorry. This is 0. Ada 0. And then the payoff is 0 for this one. I'm sorry. Payoff 1, game value 0. If we have pure strategy, so the game value is 0. But for the mixed strategy, the game value is with the probability 0 point something something. Like this one. 0, this is payoff 0. Sorry. This is different with scenario. Stable solution. Okay, stable maximum equal to 2 mass, stable point, stable solution. So this is for each strategy. We can choose this for dominated. So for the price, we see for the we remove the
smallest number.
For this one, we remove
Largest.
Okay. For variation 2, we have minimums. Okay. For this one, we have probability. Okay, this is for the last variation, variation 3. The differences is in the payoff factor. So like this one. Okay.
How many months? Three months. Damn.
Okay.
You're not training hard enough.
Like this one. So to solve this, first step for the dominated. And we check for minimas and maximum. So for this this is polydivision 2. So we take a look for terminated and unterminated. Okay, the first one, from this one, we check there is maybe domination between strategy. So, strategy. The first one, 0 and 5, this is largest. So, 2 a strategy 2 dominated strategy 1. And then minus 2 and 4, so this is largest. So, this is dominated. 2 dominated. But in 3, this is minus 3 and 2, this is the largest. So, strategy 2 is not dominated strategy 1 because this one. We take it from strategy 1 and strategy 3. 0 and 2, this is largest, this is largest, this is the largest. So, this is no dominated and then 2 and 3, this is largest, but this is largest, 2, largest, and largest. So, the minimum one, this is we can remove. So, we draw. So, we have like this. We then look for from polydivision 2 perspective. 0 and minus 2, this is dominated. 5 and 4, they dominated. So we remove the maximum one. Like this. Okay? And then minus from the line point, we remove the smallest, but for the column, we remove the largest. And then the next one, we take a look from this one. Then minus 2 and 2, this is the largest from column, but from this one, from lines, this is the largest and this is the largest. So we cannot seek for the saddle point for this. And then the second one, we search for minimum and maximum. The first one, we seek for
Maximum.
And then we search for
Minimum.
and then we seek for minimum. This one. We search for minimum.
2.
And this one. This is we search for
Maximum.
But if we take a look from the minimums, this we call it minimums. This is we call it maximum. We don't have equal number. This is 2 and for maximum they have so they don't have any section point. We can solve it with the next. So we will not use strategy anymore. have a saddle point because the minimax is different, not equal with the maximum. No saddle point processed by eliminating eliminated point. So if we eliminate like this one, eliminate because of eliminated column and row, column with largest, so we don't have any saddle point. So for variation 3, maximum is not equal to minimax, no saddle point. Unstable solution cannot be solved with the pure strategy and solved with the mixed strategies. So for the mixed strategies, we have we can this is the algorithm for the mixed strategy. The first one is analytical method. The second one is the graph method. Matrix algebra method, and we use linear programming method. For this one, we must like this one. For this one, we model it in one mathematical model. One is algebra and graph method. So the first one from the analytic. This is using evaluation. So we can solve like this. This is the same pair of table with this one, with table. And then we solve it. We have maximum column 6. So if we have 2, matrix 2, cross with 2, matrix 2 and 2. So for company A, we have a player A and player B. They have two strategy, both of them. They have 2. This is table payoff. We have 2 strategy and 2 strategy. We can mix strategy with analysis. So this is 2, 5, 6, 1. We seek for the maximum. We seek for the minimum. For the company A, we assume that strategy A, they have probability P. So for strategy A, we have probability P. And we have P. And for strategy A2, 1 in P. Because the probability is equal to
reverse
1. So P, this is 1 minus P. If company B, they determine the strategy B1, so the maximum the profit that came from the company A is 2P, 2P plus this one 6 1 okay. So 2P plus 6 minus 20P. So we have 4P plus 6. Okay. The next one, strategy optimum, where if company B steady determine strategy B, so the profit they get from the company A is from this one. So 5P plus 1 and then we have 4P plus optimum, we make this equation is equal. So minus 4p plus 6 equal to 4p plus 1. Okay? And then they have 6p equal to,
5.
so for the p is
5 for 8.
this one. Remember? So for this one, zero. This is from 5. This one. So this is for strategy. For strategy itu we have 1, 2, 3, 4. So we have
0,175 275 3.
and then so the profit for company A is 2p plus 6 1p equal to 2 profit from A 2p plus 6
Times 0.375.
and then is equal to 2 we have this one and 1 2 we have 5p plus 1 5 we have this. This is for company A. For company B, so we can assume that strategy B, they have probability P. So in this one, this is key. Oh, this is key. This is 1. Okay. The same way to the same algorithm to solve this one. So 2p plus this one. So we have the second one. Second one is this one. We make equal. So we have. So P is
0.5.
strategy B. So this is strategy for each player. So we can use analytic method. Okay. The next one. This is for moderate with linear programming. So we have some decision variable. This probability of player one using a strategy. YG is probability of player 2 using strategy G. G is 1 to until n. PEG is playoff if player 1 use pure strategy B and player 2 use pure strategy G. This is for linear programming. The sum of x1 is the probability is equal to 1. The probability is equal to 1 for player 1. For player 2, the probability is equal to 1. This is we call it value of the game. So if the pure strategy, the value of the game is 0, in this one, we have a value from 0 until 1. Because this is from the probability. Okay. This is the equation for to look for the value of the game. Then, in the mixed strategy, this is player 1, this is player 2. This is the generalization. If we have more than 2 strategy and for player 1 and 2, we have expected payoff. This is expected payoff. We have minimax theorem. So, if mixed strategy are allowed, the pair of the mixed strategy that is optional according to the minimax criterion provide a stable solution with phi is equal to phi of the value of the game, so that neither player can be better by unitarily changing his strategy. The optimal solution, the first one, player 1 choose the x1 strategy that maximizes the smallest equal expected payoff.
Mati Bu.
Yang menulis ini this is more than 2. For player 1, choose the smallest equal or maximum equal. For player 1. We choose maximum equal. Smallest equal. For player 1. For player 2. You can choose a strategy that minimizes so we choose minimize branches. This is the equation for this strategy. And then the example of the variation trees, maybe we have like this. So for player 2 and 2, this is the same category use. So we can look for cumulative. This is the largest, this is the largest. So this is not cumulative. This one and this one. 2, this is the largest, this is the largest. This one and this one. This is the largest, this is the largest, and this is the largest. So we can remove this one. Okay. The next one, 2 and 1. This is the largest, this is the largest. So not cumulative. And then 2 and 1. This is the largest, This is the largest. So we have to make it. This one. This is the largest and this is the largest. So we remove the maximum. Okay. We can use if 2 and 2 we can use the analytic method. This is mixed analytic, so we can mix like this one. So this is for player 1, player 2, and player. This is A, B. So this is P. In the analytic we P, or we in this slide we can give XA. This one. This is XA, 1 and 2 minus XA. This is simply P. This is 1 minus P. So we make analytic like this one. Simple expected way of this one. Like the analytic method, we have like this one, this strategy, and we can use like this one for A and B. This is for A. From the perspective of player A, player 1. This is for perspective of player 2. So maybe we show it in this web. So for player A, we have 2 XA plus with minus 1.
1 minus XA.
So
XA minus 1 plus 3XA minus 1.
the next one.
Minus 1 XB. XA.
XA plus 3.
3XA
Okay.
minus 4XA times plus 3.
Make this equal. So we have center XA. So we have XA is XB. XB is 1 min
XA
So
7 per 4.
like this. This is for player A. For player B, roll player B, so E 2 minus 1. Yes. V is this one. We use this one. This is meeting. This is it. So we can compute that mix strategy chosen by player A. Player A. XA is
5/7.
4/7. This is XB, this is 0. And then for player 2, we choose 4 only. This one. Optimal game is 5/7. Okay? This is the problem of two-person zero-sum game can be solved by graphical method. Each pair of tables form a matrix of 2 multiplied with n. So, in this activity we have 2 but if we have 2 and maybe more than 2 this is or like this, we can use a graphical method. Okay, for 2 and n or n and 2. So like this one. If we solve with the graphical like this, if we not remove the first strategy, we must make a graphical. Okay, what is so if we have maybe 3 strategy and 2 and 3. 2 player 1 2 and player 2 even 3. So we have 0 plus yeah. And plus 5, 1 into x1. The second one is plus, and then the next one is 2. So this one 5 mean like this, and then like this, and then like this, this one. We will make this one, and then we make it plus. Oh yeah, sorry, Mickey. Oh yeah, me. This we have 3, so we make a graphical. This is must be used ruler. Make a scala. We have a scala. This is for 0. This is for 1. Okay. Please make a scala because this is determine the solving solution. So for the first one, if x1 is 0, so we have 5 minus with 5, 0, so 5. This is 5. If the x1 is 1, so 5 means 5, 1. So this is 0. We take a 5. The next one, minus 6, 1. If 0, so we have 4. Okay. If they have 1, so this is minus 2. So we make 1. Like this one. The next one, 5x1. If x1 is 0, so this is minus 3. And then if the x1 is 1, so this is 2. Because there is no scala, we can do this one. This is big scala, like this one. Because if from perspective 1, we take a look for the maximum smallest equal or maximum equal. We take a look for the smallest equal. Smallest equal in this, smallest in this one. For the largest is in the upper. For the minimum or the smallest, we take a look from the lower. So the small, this is player 1, maximum smallest equal. So we take like this one. We take for the maximum in this point. And this point, we take a look for this red line and the green line. This is in minus 3 for the green line, with green line. So we make equal to the red. Like this one for the 3 strategy. So this is the maximum. This is minimum equal for player C marked by the boundary line, that is the lowest of the line that we have. Maximum equal for the player 1, the highest class level located at the minimum equal cut-off line. So this is, we calculate it and we have this one. Okay. This is from the perspective of player 1. This is for player 2. So here 1 is 0. From this one, we have x1 line cut off of 4 and yes. From this point, we have v2 and 1 and v2. This is for the player 1 and this for the player 2. This is we have x1 second per 11, x2 for per 11. The maximum point for player 2 is generated from the intersection between player 1 equal trace if player 2 choose pure strategy 2 and 3 from this one. If we take a look from this red and green is from this one. So this is for strategy 3 and red is for strategy 2. So from 2 and 3. So if we take a look at this one. So this is V2, 1 and V2. This is the same calculation. This is 0 because from this one, from this graph. Like this. We calculate the same way. The same formula. This is, we have like this. For strategy 1, this one. x1, x2, and the fee is the same. This is Y2 and Y3. This is Y2 and Y3. This is the same. Optimal value. Okay. Any question maybe?
Sorry Bu, I have a question. Is there any like the line? Is it always have to be like two lines and then one line from below the top, or is there any case where there is
Any
two
other?
lines?
Okay. This is for player one. Okay, next one is for this is for player 2 and 10. This is let's see. This is player 1. Okay. This is ranking. We have like this one. 2 and 3. We look like this. 5 and 8 1 like this. If from perspective x1, this is the same in this one. Wait, this is the same. But for m and 2, this is the other case. Like this one. In player 2, they have 2, but in player 1, they have 4. Strategy. And then we calculate. If we take accumulated, we can remove this one, but for we can make 4 or 3. So like this, we make some equation here. This is from perspective player 2. So we have 2v1 plus 2. So we have okay, so here, this one.
Okay.
We have this equation. For when 2v1, this is 3 minus v1, 3 and 2v1, and then we make it in the bracket. Right. This is x0, x1, and then the first one, if y1 is 0, so we have 4. And then if y1 is 1, so we have 4 with 2 is 2. This is the first line. The second one, 3 mean y1. If y1 is 0, we have 3. If y1 is 1, this is
2.
2. The next one, if 3, 0, 1 is 0, so we have 3. And then, if y1 is 1, so we have 1. The next one, if y1 is 0, we have 6. And then y1 is 1 means this. Like this. So this is view from perspective 2. For player 2, we must take look for minimax largest equal. So we take look for the largest equal. So we look at this from For minimum. This is for player 2. The other case. The different case. This is for player 2. This is from blue and purple line. This is from the strategy and dari 6 ya, sama yang ujung itu yang 3 sama so this is V1, V2, so this is this one. Ini kita yang sama, the same blue, so this is the mixed strategy for M. If we have like this one, this is for player 2. So which line that we must be for the optimum? This is player 1 or player 2? Player 1. So this is
Maximin.
Which one?
The
This one?
yes.
Oh, this one.
The red one.
Maxi smallest equal. So this is the smallest equal. We have the maximum.
Yeah.
Okay? Apa ini berarti? Garis warna equal 1 and equal 2. Okay, the next one. Is it player 1 or player 2?
Player 2.
Player 2. So
Red.
this is the
Minimax.
cross line. So this is the optimum. Okay. Any question? Pertanyaannya sudah dijawab kan tadi?
So the maximum is for player 2, is it the green line?
Green line and red line. Because player 2 is minimize largest equal.
Green.
So the largest equal is the
Red line. Green.
minimum. Okay. Red and green. But for this one, player 1 is maximum smallest equal. Smallest equal in this one. We can look for the maximum. The next one, the method to solve the game theory is use linear programming. So like this, for the problem of the 2 sum case, we make like this one, player 1, minus x, minus x n plus 1 plus b. As adjective, this is the way of x n is the probability. We have like this. So, for the example, we have this way of player, regular way of table. So, this is maximum value is positive. So, this is 3, 1, 3, like this. So, maximum value is positive. So, k is equal to 0. Maximum is 0. Maximum value negative. K more than equal to maximum value. Maximum is minus 3. So there is a probability of value no feasible solution we add with the constant k. For example, 5. This is depend on you for make a mathematical modeling. So this is up to you. You can use 5, 6, 7, etc. It's okay. And then this is the linear programming that will way off. So we move this one. So this is k11 x1. So this is x4 minus 2k, pay x1 1, x1, pay 2 x2. So maximize fee, minus 25. This is the pay off. This minus fee, fee power, it's okay, up to you. So with fee power, we call it x4. So we can show with a rainbow, and we have this is x4, the value is like this. X1 is 0.44. This is probability. And then for the 2, GA4 minus 2k, we have the same. Minus. This is up to you 5, 4. Yes, we have the same probability. So this is the result of the equation. This is the second equation. If we have like this, layer 1 we have 5, layer 2 we have 5. We can use eliminated or eliminated color and hue. This. Okay. We try the first one. We can look for mana yang mendominasi dan which is dominated. First one. This is with this. Please take a look for the line. This is largest. This is largest. No dominated. 1 and 3. This is dominated. This is the same dominated, but this is the dominated. So this is no domination. 1 and 4. This is dominated, this is dominated, but this is dominated. No domination. This is largest, but this is largest. So we cannot use this one. This is and this is the same. This is largest, but this is largest. So this is and this is. This is largest, this is largest. No domination. 2 and 5. This is largest, but this is largest. No domination. 3 and 4. This is no domination. In 3 and 5. Domination, no. And then this one. This is largest, but this is largest. No domination for 4 and 5. So we take a 4 to go. Like this. This is one, this one. This is 1 and 2. This is largest, but this is largest. Oh, 1 and 3. This is largest, this is largest, this is largest. 1 and 3, no domination. 1 and 4. This is largest, but this is largest, no domination. 1 and 5. This is largest, this is largest, no domination. The next one, 2 and 3. Domination, no. This one and this one.
Yes.
This one. This one, yeah. This one. This
Yes.
one. This one. this one. So we remove this one.
Hey yo.
Okay. We have the other one. So it is 0. Okay, this is the student who will number. And then this one and this one. 1 or 1 this one. 0. But this one. Ini besar. 1. This is largest. So we take for the column right here. This is largest. This is and this is 1 and 3 largest. No. 1 and 4
Largest.
largest. No. This one and this one
Largest.
largest.
Sama.
This is largest. No. 1 and 2. This is largest. No. This is and this is largest. No. This is and I'm sorry, it is here. 2 and 3.
Sama.
Same. Largest.
Damn.
So we remove some.
Smallest.
Jadi step by step we remove the strategy. The first one we remove this. The second one we remove this one. Third one we remove this. Remove this and we have this. If we have 3 and 2 we must use graphical method to look for the info. This is if we take it like this, so we take it for the player 2, so minimize largest info. This one, so minimize largest echo. It's like minimize largest info.
Green.
Minimize left and penetration
All good.
easy.
Inshallah.
For the mid accent, this is close book. So please prepare close book. From the first one, network, and then dynamic programming and Kindle. And from network, and then Kindle and dynamic programming. Dynamic programming is only in deterministic, not in probabilistic. Probabilistic from Kindle and from network. This is any kind of network can be suspect or minimum spanning tree or maximum flow graph or logic.
So 3 question.
The equation maybe, but there is a point A, B, C, D. Please prepare because close to you can use calculator. Please bring your ruler because we must make some practical.
So you would like that word dynamic programming for determination, probabilistic, can tell you. And then
3.
nothing.
3.
Yes.
Okay.
Okay.
Lagi? Any other question?
Dynamic programming have you got udah. Network udah. Ya. Insyaallah.
Ya.
How about inventory model? Is it going to come up?
This is include in deterministic probability.
Dynamic programming.
Deterministic dynamic algorithm.
Oh,
This is include
yes.
this.
Okay. All all good.
But please concentrate in the deterministic and read something.
For apa yang sekarang game teori bakal ada 5 strategi gitu.
Bisa jadi.
Bisa jadi.
Bisa jadi terus kalian lakukan kombinasi ini supaya bisa jadi 2 kali M atau N kali 2.
Strategi ditentuin dari soal.
Terus.
Oke.
Dia masih banyak semua dari
Lima kali nggak usah dibelajarin.
Ingat lah.
Deterministik belajar. Deterministik ranking programming.
Sama untuk data-data yang tadi apa yang tertera dari matriksnya itu bakal ada di soal kan Bu?
Yang mana sih?
Ya, ya kayak gitu ya Mas. Itu 1 0 gitu-gitu.
Yang mana sih?
Ya kayak gitu. Ya 1 2 3 salah.
Yang ini bukan tertera di soal. Kalau yang ini enggak.
Oh ya.
Udah sendiri.
Jadi kita tak boleh kalau buat seperti itu.
Tabelnya yang kayak gini ada di soalnya. Biasanya.
Oke.